Welcome to your answer key for Unit 3 Check for Understanding practice test. So I'm not going to go through a lot of the strategies in order to how I got to the answer, but I will certainly draw as we are going along and flipping back and forth between this practice test and also the periodic table in order to find our answers. So the first thing is to draw the Lewis structure for tellurium. First thing we have to do is find the element tellurium. On the periodic table, on here, I move myself up to the side over here. We find tellurium right here. Tellurium is in group 16, or group 6 if you're looking at your periodic table that is printed off. So you'll find 6A at the top of where tellurium is. So that's going to tell us how many valence electrons it has, and that's what's going to tell us how many dots it's going to need to have. So I'm going to click back to here. So you click show your work, and then you're going to draw the symbol for tellurium, and then literally just 6 dots. Ideally, you've got 4 sections around the symbol. So those are not the most beautiful dots, but as long as I see 6 dots, that would be considered to be correct. When you are done, you'll hit the check mark. And you are done on number 1. Moving to number 2, the Lewis dot structure for francium. So clicking to the periodic table, find francium on the periodic table, and you'll find francium right here in group 1. You're writing the symbol and writing 1 valence electron. So I have Fr with 1 valence electron. That is, again, a little squiggle, doing the best we can to. If you want to do a circle, you can also insert a circle by doing it this way as well. So you can draw a circle as your electron as well. Whatever you feel is easiest whenever you're using the tools that we have. All right, so there's number 2. And then we need to then match the element with the correct number of valence electrons. So we've got sodium. Okay, looking at sodium. Sodium has, okay. And group 1, it's going to have 1 valence electron. That one's already matched up. Then we got sulfur. If I need to find sulfur on the periodic table, so sulfur. Here we go. Sulfur is going to have 6 valence electrons. So this is not going to be the right spot. So we're going to need to find where we see 6 valence electrons. So there we have 6 valence electrons. So we need to drag this sulfur on down to, can slide it down. Oops, there we go. Now move that, keep moving it down. Here we go. Move down to 6 valence electrons. We're at 2, 4, 5, and here we have 6. So we got that is all matched up there. Oops. Here we go. And now the next one to look at is we got neon. Neon on the periodic table. Find neon right here on the periodic table, and it's going to be in group 18 or group 8A. So it's going to have 8 valence electrons. Right now it's matched up to have 3. So I'm going to grab that neon, move it down until we get to that 8. Keeping moving on. And here we have neon having 8. So we're getting closer. All right. So we've got sodium, and then we have silicon right there with 3 valence electrons. Finding silicon on the on the periodic table. Here's silicon. Silicon is on group 14, so it's not going to have 3 valence electrons, but it's going to have 4 valence electrons. So we're going to need to take this down to the number 4. So we're getting closer. Boron, finding boron on the periodic table. Boron is right here, so it's going to have 3 valence electrons. There we go. We got that matched up. We got our sodium matched up. We have our boron matched up, and now we need to find bromine. Does bromine have 2? Bromine does not have 2. Bromine is right here on the periodic table, so it's going to be having 7 valence electrons. It's in that group 17 or 7A. So moving this one down. Noticing that my Chromebook just does not have that nice feature to be able to scroll down as well. Maybe those of you on your computer are able to have that there. All right, so here we have bromine having 7. Our last ones to check here are going to be, we've got 3 valence electrons. We got that silicon popped away from that 4. So does sulfur, what does sulfur have? Sulfur going to here. Sulfur is in group 16. So group 16 is going to show us 6 valence electrons. It does not have 2 valence electrons. And we're going to move that down till we get to 6. All right. So we got 6 valence electrons, 7 valence electrons. Here we have phosphorus. I'm going to check for phosphorus. We haven't had phosphorus yet. So here we have phosphorus. Phosphorus is going to be in group 15. I mean, it has 5 valence electrons. We have 5 valence electrons. Radium, I'm going to double check on that radium. So here we've got radium in group 2, so 2 valence electrons. So it's all lined up. There are your answers for that question. That one took a little bit longer than expected because of the technology. So we'll see if I decide to put that question like that on the actual assessment tomorrow. But I will respond to those of you that already completed, and maybe I'll get some feedback on whether or not we have that matching one. Then number 4 on the periodic table is separated into metals, nonmetals, and metalloids. On the provided periodic table, draw the metalloid line that separates the metal from the nonmetals, and the same on the periodic table, circle 3 metals in red and 3 nonmetals in green. What's nice about this formative is when I click on show your work, you're going to see the question is here on the right of the periodic table. So when I did our tutorial, this line was still there. So giving us a general, you can draw it however you would like. I'm going to actually erase this line. I think, maybe not. Oh, there we go. So you can do it in however you'd like. You can do it. I encourage you to do it in the scribble. Maybe I'll do this in thickness and a little bit thicker. And so I'm going to draw that line, giving us this little line here. So something in this zone. So if you have like not the most beautiful line, that's okay. So I'm doing the best I can on here. Remembering on the periodic table, you can find it. It is going to be, if I click on here, excuse me, on boron, I'm going to see that it's going to be a metalloid. Circling here is in the series of metalloids right here, right here. It's not, it's a transition metal. So once I get to germanium, arsenic, antimony, tellurium, polonium, and astatine. So, oh, excuse me. So it gets a little bit there, astatine there. So it gets a little bit weird with the polonium, but know that you'll have a general line on your assignment there. Then we need to circle 3 metals in red and 3 nonmetals in green. So I'm going to choose red. I'll choose any 3 metals anywhere on this left side of the metalloid line. And then I need to choose green, and I need to circle 3 nonmetals. That's not the most beautiful line, but you got 3 nonmetals on there. So there's your answer for that question, number 4. Then we get to question 5. Draw the bond that occurs between lithium and bromine. So again, looking at the periodic table, I'd find lithium being in group 1, bromine in group 7. Remembering that octet rule, lithium wants to give away 1, and bromine has 7, so it's going to have, it's only going to get, 1 electron. So I'm just going to continue using green, because why not? So there's lithium. It's going to have 1 valence electron. And here we've got bromine with 7. And I'm just going to draw the bond that occurs where lithium gives to the bromine. And there's number 5. Number 6, I'm going to have sodium and oxygen. Finding sodium is right here. Sodium has 1 valence electron, and oxygen has 6 valence electrons. So I'm going to have sodium having 1. I'm going to go ahead and we know that sodium only has 1, but oxygen needs to have 2. So oxygen is going to have 2 sodiums for every 1 oxygen. So there is your answer for question number 6. Still using green. So then we got calcium and chlorine. Calcium on the periodic table is going to have 2 valence electrons. Chlorine on the periodic table is going to have 7 valence electrons, but chlorine can only take 1, and calcium has to give away 2. It's not just going to give away 1. So here we got calcium. I'm going to erase that little electron dot that I had there. All right, so we got calcium with its 2 electrons. I'm going to do 7 electrons. Calcium's giving 1, but calcium still needs to give away that other one, so that's why another calcium shows up. And here you go. That's where you would draw the bond between calcium and chlorine. And then moving down to question 8, it says circle an element on the periodic table that would lose an electron and form a +1 ion. So that means it would lose 1 electron. It would be any element in this group. So if I circled lithium or rubidium or francium, hydrogen is not going to. But anything in that group that is below hydrogen would be considered to be forming that +1 ion. And then number 9, circle and the element on the periodic table that would gain 2 electrons and form an ion with a -2 charge. So that would be anything in here. We have again this group 16 and needs to have 8 electrons. So I can circle any element in here. I can do selenium, I can do polonium, oxygen. So that would be for that one on question number 9. I just circled. I just think that will be edited whenever you see it. Number 9, circle the element on the periodic table that would gain 2 electrons and form an ion. Oh, excuse me. Number 10, draw the Lewis dot structure for gallium. And does gallium gain or lose electrons? And how many? After gallium gains or loses electrons, what charge does it become? So I have like 3 things I need to do here. I need to look at gallium. Gallium right here is in group 13, so it's going to be 3 valence electrons. Capital G, lowercase a, you have 3 valence electrons, and is going to lose electrons. And it's lose 3 electrons because metals lose electrons. It's going to lose 3 electrons. And what charge when you lose 3 electrons would be a 3+. So that would be an acceptable answer for question 10. Question 11, draw the Lewis dot structure for iodine. Does iodine gain or lose electrons, and how many? After iodine gains or loses electrons, what charge does it become? So here we've got iodine. Iodine has 7. So I would draw I. You can do it like this, but I prefer to do like a real uppercase I. And then we've got 7 valence electrons. It's going to gain 1 electron. So an E-. And if it gains 1 electron, because it needs to have 8, it means it's going to have a -1 charge. All right, almost there. What is the formula and name for an ionic bond between gallium and nitrogen? So if I'm looking at gallium, this is for the level 4. If I'm looking for gallium, I've got a 3 plus, and here I've got a 3-. So then the formula, I have a 3-to-3 ratio. I'm going to have a 1-to-1. So then the formula would be gallium, GAN, and then the name would be gallium nitride. And the ionic bond between francium and fluorine. So I need to find francium. We had francium earlier, francium and fluorine. So we've got a +1 and we got a -1, or we have a group 1 and a group 7. So francium is going to give its 1 electron to fluorine. So then we have a +1, we have a -1, and so then we have a 1-to-1. So the formula would be FRF, because francium, and the name would be francium fluoride. And no, they don't have the perfect spelling on this one. And then your challenge question is, what is the formula and name for ionic bond between radium and phosphorus? So this one's a little bit trickier. So we got radium and we got phosphorus. Radium would be a +2. Phosphorus would be a -3. Remember that little crisscross method, or if you watched some of the naming videos that were on assignment 3.5, we have that little strategy. And so the formula would be for radium and phosphorus for question 14 would be Ra3, 3, phosphorus 2. So that would be the formula for radium